Howdy, folks. Today we're going to talk about making our own functions in JavaScript. So functions are these really cool tools that basically let us put a bundle of code together so that we can refer it to it by name rather than having to type out all that code again. And so it ends up being really, really useful in a lot of ways. The two biggest ways is that one, it makes our code a little simpler to read because we can replace big blocks of code with words that mean stuff to us. But probably actually the biggest thing that it does for us is it lets us troubleshoot our code a lot better. And the reason for this is that you can think of functions as sort of like little mini pieces of code that you're going to write, check to make sure that they do exactly what you want, and then you can kind of just set them off to the side. Like once that it works, you don't never have to edit it or mess with it again, and you can set it off the side and hey, if there's a problem with your code, it's not coming from that. And so it ends up being a really big and important piece of writing bigger projects so that you can kind of isolate like, hey, this does this one thing, it does one thing well, I know what it does, awesome. I got that checked off. And so that's going to help us take a big problem and turn it into sort of bite-sized chunks. So for this demo, we'll make a couple of things. So the first one that we might make is, I have a little outline sitting here that says, Pythag. And so you know what? It sure looks like, I might have to find the missing side of a triangle, of a right triangle. And I might know the two short sides, and I want to find the hypotenuse. And so maybe I'll just call it, I'll call it find hype. So when we make a function, the idea is we use the function keyword, and then we give it a name of the function, which is going to be how we sort of call it. And then we can choose to give it parameters, which are inputs into the function. So in this case, I'm making a function called findHype, and it's going to take in, it's probably going to take in side 1 and side 2. Okay, so these are what the inputs are going to be. Okay, and then, well, what am I going to do? Well, you know what? What is the hypotenuse? Well, if these are, right triangle and things like that, hey, I'm going to make, say the hypotenuse is going to be what? It's going to be, well, the square root of side 1 squared, so just times side 1, plus b squared, side 2 times side 2. Okay, and so that is going to find the thing. And so if we calculated that, okay, that would put that variable into it. But the thing is, I actually want to get it out of the function. And so one of the cool things we can do with functions is sometimes we can just have them do something. Like maybe we wanted to find it and have it just write the hypotenuse out. Okay, so then, hey, this would be a little function that I could say find hype of 3 and 4. And hey, what do we think it's going to show on the screen when we run? Hey, look, it prints out 5. Okay, so this is just, hey, we bundled up some code, and now instead of having to type, all this stuff out every time we want to use the find the hypotenuse of a right triangle, I can just type this word and it'll do it. But this isn't, this is cool, but this just writes to the screen. Probably if I'm going to do this, I'm actually going to want to do something else with it, right? So maybe I want to, I want to multiply it by 5 or do something like that. So the big command that we can use with functions is something called return. And what return lets us do is it lets us return one value from our function. So when we hit return, it sort of ends the function. And then whatever we send back, we can sort of catch it. And so that it'll end up being, that we can put it inside of a variable. So maybe I have something like this where, I have the answer. And I want to save it into that. So if I run it, nothing's going to happen here, but you'll notice that the variable answer is holding 5, right? And so now I could do something like, write, answer, times 8. I don't know. And we can just, save it off. And you can see here it writes out 40 to the screen. Answer's 5. 5 times 8 is 40. So that's really the basics of doing a function. We declare the function, we give it a name, and then we just start using it. So just a couple of reminders is I did find height equals 3 and 4, and I could also do like var like a equals 3 and var b equals 4, and I could just put in a and b right here, and that'll give me the exact same answer. So you'll see how it pops up 40. So that's kind of a common thing with functions. This right here, how it says side 1 and side 2, they're just labels for like what the things in the parentheses are going to get called when they get sent to the function. So when I sent 3 and 4 in, like when this was 3 and 4, it said, hey, side 1, you get the value of 3. Side 2, you get the value of 4. When I do it like this, well, it says, hey, side 1, you get the value of a. What's the value of a? Oh, the value of a is 3. Hey, side 2, you get the value of b. What's the value of b? Oh, it's 4. So you're going to be 4. So they don't have to like match up with names or anything like that. It's just, hey, what are the labels here? So a lot of times I write my functions with really descriptive variable names so that then I can really be clear and troubleshoot things, because I don't have to type it out ever again, basically. And if once it's working, then I can do that. So hopefully this makes sense. Now I want to make this is a helper function, right, that we're actually going to use a lot in the problem of the week this week. So the video, not the video, what we did in class is we're going to build up a specific function. And the function is, I'm going to call it build a line. And it's going to take in I'm going to call it start x, start y. It's going to take in a length, and it's going to take in an angle. So the idea behind this function is, length is a reserved keyword, so I'm just going to call it len. So the idea behind this is that sometimes when I want to build a line, I want to build it between 2 points. Like I know point 1, I know point 2, and I want to connect the two of those with a line. But actually, I would say even more often, especially if we're making games or things like that, is that we know where we start, and then we also kind of know like the heading that we want to do. So, instead of this, it's like I'm standing here and I want to walk 5 feet at, sort of a 30-degree angle. So I turn my body and I walk forward 5 feet, and then I'm at a different spot. And so we just have to do a little bit of the math around that. If you want to see like the actual, like, how did I figure out the math, we can do that. But ultimately, it is just a little bit of right triangle trig. And I'll link another video that I've gone through the math in. I think I have one already recorded, but I'll record another one real quick if you need to. So what are we going to do? We're basically going to use just good old SOHCAHTOA. And what we're going to do is, if I know the hypotenuse and I know the starting point, I should be able to figure out the lengths of the other two sides if I know what angle I want. So to get this to work, we need to do a couple of things. I know the starting x and the starting y, and what I really need to calculate is the ending x, okay? And I need to calculate the ending y, because those are going to be the endpoints. That's the result I want to have, okay? And then once I have that, I want to, like, once I know those two things, the thing I want to do is, hey, I'm going to call it finished line. And it's going to be a new line that has, well, start x, start y, end x, and y as the points in it. Cool. Let's call it something shorter so it fits on the screen. We'll just call it, I don't know, we'll just call it my line. So this is like what I want to end up with, okay? And because this is what I want to end up with when I'm making my function, and actually I want to have like the actual like line object to do stuff with later on, I'm going to return that line that I made, okay? So the reason that I'm doing it like this is so that you can see that I'm actually doing like a lot of like the structure of the program, and I don't need to know how to do the math yet, right? Like I know that like I'm gonna have to find the value of this x, I'm gonna have to find the value of that y, which is gonna require us to do a little math. But I know once I have those, I'm gonna build a line. And then once I have that, I'm gonna send that line back to my my program so I can catch it in something else. So at the end of the day, then I'll be able to kind of use this function. I'll just call it, I don't know, I'll call it this line equals what? Well, it's going to be build line, and then I'm going to just give it some values that I sort of think it is. Hey, you know what? I'm going to put this in the roughly center of the screen. Canvas dot width divided by 2. Canvas dot height divided by 2, and I'm going to give it a length of 100 pixels, and hey, let's give it a 45-degree angle. Okay, and then I'm going to do this line dot draw. So this is going to be, I already came up with a test case. Okay, so this is the other part that's often really helpful when you're writing something, is I know in my head what a line in the center of the screen looks like. I know what about 100 pixels look like, and I have a sense of how 45 degrees should be. And so if I understand those things, then I can draw that. And so then that's a way for me to check my math at the end. Okay, so cool. What is the math that I need to do? So in this case, I need to find I'm finding like the length of, I'm going to use like the length of the missing side. And so if we sort of imagine it in our heads, the x component, here's the point, here's the angle. The x component is going to be the adjacent side, and the y component is going to be the opposite side. And so that means for the adjacent side, I'm going to use a little ka, or the cosine of SOHCAHTOA. So what's that going to look like? Well, turns out that in this case, we can just go in. We are going to go from our starting x, and what are we going to add? We're going to add 1 plus the length times cosine of, well, our angle. And put that in there like that. Okay. And again, I'll throw in a little video that goes over this math so you can review this math if it's not something that you're super comfortable with. But we're using that good old-fashioned right triangle trig, and I don't know, I'll go over the math in class too. So here we go. So we got sine of the angle 2. Okay, let's see how that goes, right? Like, okay, we got cosine of the angle, we got sine of the angle. Let's run it. And oops, got a typo. Classic. Okay, now that is a line, so I'm happy about that. It looks a little weird though. Like, it's a little hard to know if it is. I mean, there's a layer that this could be a 45-degree angle, right? Because like this is 90, this is that. But like, which way should it be pointing? Okay, so that's kind of a good question. And also, if we actually go into docs here and we look up like sine, okay, maybe we look up the sine function here, notice that when it says here, it says return the sign in radians of a number or nan if the parameter is not a number. So this is one of the things is that we gotta make sure our angle is in radians, not degrees. So little mistake there. So got to make sure that we do that. And so I'm just going to make a new variable called angle in rads. And again, the math is pretty simple. We're going to do the angle times. And in this case, we have pi as a built-in math number. And we do pi divided by 180. So that's going to convert our degrees to angles. The reason for that is, well, there's 2 pi radians in a circle, and there's 360 degrees in a circle. And so our conversion is 2 pi divided by 360, which reduces to pi over 180. So then we just got to do angle in rads here, angle in rads. So we got a little, lost in the math there. Don't worry about that too much. So now we run it and see that looks a little bit better. So we've kind of figured out that this line, 45 degrees, you know what? Let's do a little experiment here. What would happen if we put in 0? What do we get? And we can see here that this does a little bit of like the 0 is right here, and it's sort of going around a little bit like clockwise like this. So if I went negative 45 degrees, it goes up there. And if I went, I don't know, let's go 90 degrees, it's going to be pointing straight down. So we can kind of figure out that 0's here, 90, 180, 270's up here. So it's going clockwise from 0 over there. And so that'll help us kind of figure out where we're going. And so we can either go negative or we could go positive. So if I did, like, for instance, 315, that's going to give me the same thing as negative 45. Okay, so we built a function with something that we're actually going to use here, so that should be pretty good. And ultimately, I think this will just give you a good place to sort of base this off of and check. And we're going to build a lot of functions this year, so hopefully that's comfortable for you. Peace.